Okay, now we get to the mixed example. So now I'm not specifically telling you this is grouping or highest common factor. So you need to go through the checklist in your mind. When your question says that you need to factorize, you need to think, okay, that means I need to look for highest common factors. I need to look for dots. I need to look if I can factorize as a trinomial, and I need to look for grouping. Okay, hence, always look for a common factor first. And then make sure that it is fully factorized. Often a question is like 4 or 5 marks when there's more than one method of factorization in there. Like first you have to take out a common factor, and then maybe then it's dots, and then students stop just after taking out the common factor, and then you lose most of the marks. So try and avoid that. Okay, let's look at the first one. Let's go through the checklist in our mind. Start by looking for a highest common factor first. There is one. Both terms, the two terms, has got a 10 that we can take out. Left over goes into set of brackets. Then we are left with a to the power of 20 in the first term, and then 4 in the second term. Okay, so let's investigate. Is it fully factorized? What did you say? What's going on inside the brackets there, grade 9s? Dots. Two terms separated by a minus, and both those terms are perfect squares. A to the power of 20 is a to the power of 10. Do you remember? So that's a to the power of 10 that goes into both brackets minus 2 plus 2. Is it fully factorized now? Well, yeah. If we look at this one, it's tempting to say that it's dots again, but 2 isn't a perfect square, right? So it means it's fully factorized. Okay, let's look at the second one. Is there a highest common factor? No. Is it a trinomial? It doesn't take on that form to factorize it as a trinomial. Don't have to group, there's just two terms. So, two terms separated by minus, and both those terms are perfect squares. One is a perfect square, and a to the power of 8 is a perfect square because it will be a to the power of 4. Let's put that into two sets of brackets. A to the power of 4, a to the power of 4, 1, 1, 1 plus, and 1 minus. We need to make sure that it's fully factorized. Let's see. Is it? First bracket is done. Second bracket, that one. Do you see that it's dots? Why do I say that? We just carry that bracket. This one will break up into two sets of brackets again because it's dots. Why? A to the power of 4 is a perfect square. It will be a to the power of 2, a squared. And 1 we know is a perfect square. 1 plus and 1 minus. Is it fully factorized now? Well, we know this one is done. So we can just carry that one over. The second one is done because there's a plus in between. Do you see this one? Dots again. Two sets of brackets because the square root of a squared is a. The square root of 1 is 1. 1 plus, 1 minus, and thank goodness we are finally done. Okay, let's see what's next. All right, let's investigate. Look for a highest common factor. No, it's not dots. Is it the right form to factorize as a trinomial? We've got x squared, x to the power of 1, and then a constant. So it looks good. So it will break up into two sets of brackets. What do we need to do? We need to take the factors of the constant term, the 10. 10 times 1, 5 times 2. Those are the factor pairs for 10, right? Now we need to play around with the factor pairs, add and subtract them to see which factor pair is going to get us back to plus 3. So let's see, is 10 and 1 going to get us back to plus 3? I don't think so. 10 plus 1, 10 minus 1. What about 5 and 2? How can that get us back to plus 3? Well, it will have to be plus 5, take 2 away. And then those are the factors that goes into our set of brackets. And if we multiply that out, we will see that it will get us back to that trinomial. So it means it's correct. Let's look at number 4. Now, the moment that a lot of students, when they see fractions, they lose their marbles and they think now all of a sudden it's very difficult. Not necessarily. Is there a highest common factor there? Doesn't look like it. Doesn't look like a trinomial. There's only 2 terms. We don't have to group. Let's consider dots. 2 terms separated by a minus. Yes. So now the question is, are both those perfect squares? We know that y squared is a perfect square. So now this is where square root laws and knowing your perfect squares also comes in, grade 9s. So the square root of 64 is 8. And the square root of 9 is 3. And you need to know that you are allowed to get those square roots because it's just one term underneath the square root. So 2 sets of brackets, 4 dots, square root of that, square root of that, 1 plus, 1 minus. Check if it's fully factorized. Yes. Okay, so don't freak out when you see fractions. What's going on there by number 5? Well, we know we're supposed to look for our highest common factor first, right? It's often handy. These 3 terms, what about 3? If we take out 3, left over in the first term, left over in the second term, left over in the third term. Is it fully factorized? What's going on inside the brackets? Do you see that it looks like we can factorize for a trinomial there? Because I've got y to the power of 2, y to the power of 1, and then a constant. It will break up into 2 sets of brackets. What do we need to do? We need to take the factors, or we need to get the factor pairs of the constant. 21 and 1, 7 and 3. Is there another one? No, I think that's it. And we need to play around with the factor pairs, add and subtract them to see how are they going to get us back to that middle term of 4. 21 and 1 is not going to get us there. 7 and 3, yeah. What about if it's plus 7 and we take away 3? I think that will work. So the square root of that first term and then plus 7 minus 3. So you'll see if we multiply this back out by using FOIL, it will get us back to that trinomial. And that's fully factorized. Okay, we've got 2 more to go. If we look at number 6, is there a highest common factor in all those terms? Cheapest, there's a lot. 1, 2, 3, 4, 5. Is there a common factor? No. But do you see the like terms? We can just put those together. See, we've got negative 4 and we can take away 2 there. We can simplify those, put those together, and we can put those together. They are like terms. When we do that, okay, so let's just keep the x squared there. There it is. If we put these 2 together, it will give us plus 5x. And then if we put those 2 together, just our integers. Okay, now let's reevaluate. Well, that looks like it takes on the right form to factorize as a trinomial. We've got x squared. We've got x to the power of 1 and a constant. So that will break up into 2 sets of brackets. What do we need to do? We need to take the factor pairs for 6. So 6 and 1 and 3 and 2. We need to play around with the factor pair, and see if it will get us back to the middle term of plus 5. Okay, now this is an interesting trinomial because look at the 6 and the 1. That can get us back to 6. Okay, get us back to plus 5. If it is plus 6 minus 1, it will get us back to plus 5. And if it is plus 3 and plus 2, it will also get us back to 5. So now we need to see which one is it, or do both of them work? So if I say x plus 3 plus 2, let's multiply it out and see if it works. X squared plus 2x plus 3x plus 6. That's not going to work. Do you see why I'm saying that? Because there's a plus 6, there needs to be a minus 6. Okay, so let's check the other one. It is just worth checking. Can you see that? So, oops, didn't mean to do all that. So we've got, what was it? Minus 6 there. So let's choose the other factor pair. So we've got x plus 6, x minus 1. If we multiply that out, x squared minus x plus 6x and then minus 6. This one is going to work, hey, because if we put that together, it will be plus 5, and that will get us back to that negative 6 that we need. So this is the correct one. So also just be mindful of that. It would be very annoying if you make that mistake. Okay. Last one. Now, let's read carefully. That would be the first step. It says that, we need to use factorization. So that means we can only use those 4 methods. Highest common factor, dots, trinomials, and what's the other one? Grouping. And then we need to calculate. So when we calculate, it means they want the value. We're not allowed to use calculators. We need to show our working. Okay, well, we can do that. We're not going to lose our marbles when something looks a little bit different. So let's just investigate and see what's going on there. Well, they said that we can only factorize. So is there a highest common factor? Well, we can't pull out an 8 because it's 8 and 28. So it's not the same thing. We can't take that out. And we can't take out like a common factor of 2 because remember, this is not a normal 8. It is 8 squared and it's 28 squared. So we can't just go and divide that by something. Okay, what about, it's not a trinomial, what about dots? Does it take on that form? It's 2 terms separated by a minus, and those are both perfect squares. How do we know that these are both perfect squares? Well, when something is to the power of 2, it is a perfect square. So, dots. Let's try and see if that can work. Normally, for dots, we put it into 2 sets of brackets. What goes into the sets of brackets? Well, the square root of the first term, which is just that, the square root of the second term, which is just that, and then 1 plus and 1 minus. Okay, well, we can actually put those together because if you think about it, with all the other examples that you've done, you had something like that where there's nothing more we can do because we can't put the x and the 1 together. They're not like terms. But we can put together 28 plus 8. That will be 36. And timesing that by 28 minus 8, which is just 20. So we've got that basic multiplication. Let's take 36 times 2. 36 times 2 must be 72 because 30 times 2 is 60 and 6 times 2 is 12. So if we put that together, it will be 72 and then we just add the 0 again. And that should be our answer. And then obviously you can check it with your calculator and see if it is correct. Okay, I hope this went well and that this was helpful.